Day 5. Persistence and databases. In this day we're going to do a number of things to do with persistence within Kubernetes. We're going to start by describing PVs and PVCs, persistent volumes and persistent volume claims, a fundamental abstraction in Kubernetes used to provision storage for pods. Then we're going to install Rook, which is going to give us a Ceph storage cluster within our Kubernetes cluster. Next we'll explore Rook, have a look at some of the Ceph commands. Then we'll deploy a highly available database using Rook as the storage backend. And finally we'll finish up with some homework. Day 5. Persistent volumes and persistent volume claims. In this video we will describe how Kubernetes uses persistent volumes and persistent volume claims to allocate persistent storage into pods. The persistent volume resource represents a storage volume that can be used by Kubernetes. Persistent volumes are a subset of the available volumes that Kubernetes can use. If we go to the Kubernetes website and look at the documentation under Concepts, and then Storage and Volumes, we can see all of the available types of volume that Kubernetes can use. As you can see, there's quite a few of them. With things like the config map being an example of a volume, we saw the config map earlier on. However, persistent volumes generally represent storage that is backed by a cloud or a storage cluster. So if we go back to the top of the page and we have a look on the left side, we can see that there's a link for persistent volumes. And here we can get the information about the specifics of a persistent volume as opposed to just a volume. So if we click on the types of persistent volume, we can see here there's many different types. Things like AWS, EBS, Azure File, Ceph file system, RDB, which is the Ceph block device, and that's something we're going to look at a lot more in the coming videos. So initially Kubernetes required that storage volumes were manually provisioned by an operator, a so-called static provisioning. However, it is now more common to use dynamic provisioning, where the storage volume is created dynamically based on a request for storage made through a persistent volume claim resource. This dynamic provision is enabled by the use of a storage class resource, which we'll discuss a little bit further on in the video. So let's have a look at what a persistent volume resource looks like. As we can see, we've got our usual fields such as API version and kind, which is obviously a persistent volume, metadata and spec. So in the spec we can see we're saying that this persistent volume that is represented by this resource has a capacity of 8 GB, and we can also see it as an access mode of read write once. There's a few other things in there as well. So with the access mode, there's a number of available access modes, as we can see in this table. So the read write once, abbreviated as RWO, is a volume that can be mounted as a read write volume by just a single node or pod. But we also have read-only many, which is a volume that can be mounted by many pods, but only read-only. And then finally we have read-write many. That's generally like a file system like GlusterFS or CephFS. And that's a volume that can be mounted as read-write by many nodes or pods at the same time. So let's have a look at the persistent volume claim resource. So with this resource here, we can see that we're claiming a resource that is an access mode of read-write once, has a storage size of 8 GB. And we're saying we want it to be provisioned by the storage class Rook Ceph block, which is something we're going to deploy into our cluster in the next video. So how does a pod consume a persistent volume? Well, let's have a look in a pod spec. Okay, so as we can see, as usual, inside the container definition, we're mounting a volume to a particular path, and the name of the volume that we're mounting is myPD. So the volumes are defined as usual in the volumes component of the spec. And we can see here we have one volume with the name myPD, and that maps to a persistent volume claim which we just showed. And the claim name is myClaim in this case. So what does a storage class look like? Well, this definition defines a storage class for a GlusterFS storage cluster. And we can see it's got in there some parameters that are needed to be able to communicate to that storage cluster. So what we have done in this video is provide an overview of how Kubernetes uses persistent volume and persistent volume claim resources to represent storage volumes that can be mapped into a pod. We also discussed how storage classes are used to enable the dynamic provisioning of persistent volumes. In the next video we will install Rook, which is a Ceph storage cluster, and will give us the ability to provision our own persistent volumes to pods within our cluster.